Hello, welcome to Tennessee's at-home learning series for math. Today's lesson is for all our 8th graders out there, though all students are welcome to tune in. This lesson is the 9th in our series. My name is Candace Thompson, and I'm an 8th grade math teacher at Oakland Middle School in the Rutherford County School System. I'm so excited to be your teacher for this lesson today. Welcome to my virtual classroom. If you didn't see our previous lessons, you can find them on the Tennessee Department of Education's website that I actually have pulled up here. If you scroll all the way down underneath Resources, go to Math Grade 8, and you can find the teacher lesson plans as well as the student packet that will have the additional practice for your students after the lesson. You can still tune into today's lesson if you haven't seen any of our others, but it might be more fun if you first go back and watch our other lessons, since we'll be talking about things we learned previously. Today, we will be learning about using functions to model linear relationships in mathematics. Before we get started, to participate fully in our lesson today, you will need the following: paper and pencil on a hard surface to write on. A calculator is not required, but it may be helpful to check your calculations. Other optional materials would be graph paper, straight edges, and tracing paper. Okay, let's begin. There are many instances where a problem is not presented as an equation at all. The problem is instead presented as a verbal description, and you have to make sense of the problem in order to find an answer to the question. One strategy for making sense of the problem is to use 3 reads. In other words, read the problem aloud first, then read it again, looking for cues that will help you understand what the problem is asking. Finally, read the problem a 3rd time to determine the important quantities in the description that will be needed to solve the problem. We'll be walking through a few verbal descriptions to analyze them for pertinent information that will be used to solve the problem. Are you ready? Okay, let's begin. At this time, I'm going to take my screen off and pull up our first problem today. If you have your graph paper, straight edge, or tracing paper, go ahead and grab those and we will dive in. Kadeem spends the afternoon reading a book he started yesterday. He reads 120 pages in 3 hours. 1 hour after Kadeem begins reading, he is on page 80. Write an equation for the page he is on, y, as a function of the minutes spent reading, x. What page number was he on when he started reading today? If you'd like, pause the video and read the problem again, either aloud or to yourself. Are you ready? Let's take a closer look. Look at the information provided. You can graph the function. So let's plot the point 60, 80 on a graph. I have started with my own graph here, and I'm going to plot the point 60, 80. So I'm going to look for my x value, 60, which I see that the way this is numbered, it's going to be between 40 and 80. And then I'm going to go up to 80, and I'm going to plot my point here. From here, you can find the rate of change, which is the slope of the line. If Kadeem started the book at 0 minutes, he would be on page 120 after 180 minutes. How many hours is that, 180 minutes? Did you say 3 hours? Let's take a look. We have 120 over 180 minutes, page 120 over 180 minutes. So if we simplify that to 40 over 60, that will again simplify to 2/3. Use the slope to plot another point at 120, 120. Draw a line through the points and identify the y-intercept. It should look like this. So I have my first point at 60, 80, and then I used that rate of change, that rise of 2, that run of 3. Remember I said that the rate of change or the slope was 2/3. I used that to find this second point here at 120, 120. And then I just connected the two to draw this line here. What are some different ways of finding the initial value? You can calculate the rate of change in initial value like this: 120 pages over 3 hours. That can be written as 120 pages over 180 minutes. The rate of change is 2/3 of a page per minute. To find the initial value, use the equation for a linear function, then substitute the rate of change in the point 60, 80. So we're going to use y equals mx plus b, and we're going to use this point to figure out our rate of change, our initial value, or our y-intercept. So my y value is 80, so I'm going to plug that in here. I know that my rate of change, or my slope, is 2/3, so I'm plugging that in for m. And then the value of x when y is 80 is 60. And I'm using this, like I said, to find my initial value. So I'm going to simplify it. But 60, 80 is not on this line, so translate it up until it is. Keep in mind that each grid space along the x-axis represents 20 minutes, which is the same as 1/3 of an hour. So I'm going to translate that line up here. The line looks like it passes through 040 right here. So the y-intercept is 40. Your slope would look like this. Remember, my slope formula is y2 minus y1 over x2 minus x1. So I'm labeling this x1, y1. I'm labeling this x2 and y2. So y2 would be 80 minus y1, which would be 40, over x2, which is 60, minus x1, which is 0. When I plug that in, I get 40 over 60, which is equal to 2/3. So your equation would be y equals 2/3 x, and then my y-intercept is 40. So what this means is that Kadeem was on page 40 when he began reading. Let's look at it another way. 120 pages in 3 hours is this. So 120 pages in 3 hours is equal to 40 pages per hour. If he was on page 80 after 1 hour, then he must have started on page 40. So if you were to make a table and we did hours and pages, if for 1 hour he was on 80 pages or page 80 at 0 hours, or when he started, he would be on page 40 because it's increasing 40 pages per 1 hour. So that's just another way to look at that. So again, our equation for this example is y equals 2/3 plus 40. Let's take a look at a couple of other verbal problems and think about strategies we used here to solve and how it might be useful for the problems that we're looking at here. So it says, the energy rating for a lawnmower is shown in the box. A full tank of gas can power the lawnmower for about 6 hours. What equation can be used to find the amount of gas left in the tank Y as a function of mowing time X? So what equation can be used to find the amount of gas left in the tank Y as a function of mowing time X? As you can see, the initial value is 8 gallons, which is the amount of gas in a full tank, because this gas is being consumed and its amount is decreasing as the mower is running. So the slope is going to be negative. So your rate of change would be 8 gallons every 6 hours, which would be 4/3 of a gallon or gallons per hour. Change in the value of the function refers to the change in Y, the output value, and the change in the input refers to the change in X. So your equation would be Y equals -4/3. Remember, I know that this is a positive 4/3 that we figured out, but we said in the context of this problem, since we're mowing, it's losing gas, which is going to make our slope negative. So Y equals 4/3 X, and then our initial value, what we started with, is 8. Let's look at another problem. All right, so we have Anaya. Anaya is driving home at a constant speed. After 20 minutes, she is 70 miles from home. After 1 hour, she is 40 miles from home. What equation models her distance from home Y as a function of time X? Okay, so 1 hour is 60 minutes. Gotta make sure we make note of that. So on a graph, the points 20, 70, because it says after 20 minutes, she was 70 miles from home. So we could use those points, and we could also use the points 60, 40. Because using this after 60 minutes, she would be 40 miles from home. So we can use these 2 points to satisfy the function if we're using minutes. The 2 points can be used to find the rate of change. To find the initial value, the rate of change can be substituted for m and the coordinates of 1 point in x and y in the equation y equals mx plus b, and then the equation can be solved for b. That's a lot of information. So let's start with our slope. I'm going to label my points as x1, y1, x2, y2. So remember, our formula is y2 minus y1 over x2 minus x1. So for y2, I'm going to plug in 70. For y1, I'm going to plug in 40. For x2, I'm going to plug in 20. And for x1, I'm going to plug in 60. So that simplifies to 30 over -40, which simplifies to -3/4. Okay, so I've got my slope here. I'll highlight that for you. Now we're going to use this to figure out, we're going to use this in 1 point to figure out my initial value or my y-intercept. So I have y equals mx plus b. I'm going to use the points 2070 to figure out my initial value. So my y value here is going to be 70. My slope or my rate of change I just discovered was negative 3/4. The x value when my y value is 70 is 20. And I'm solving for b, for my initial value. So once I plug that in, I get 70 equals negative 15 plus b. Don't make this harder than it has to be. What plus negative 15? Remember that adding a negative integer is the same as subtracting. So basically, what minus 15 equals 70? And we discover that b equals 85. So if we were to write an equation for this situation, we would have y equals negative 3/4 x. There's my rate of change. And then my y-intercept, or my initial value, is 85. Here is the solution to my problem. Okay, let's think about another example here. All right. Tressa is stocking small paint cans on shelves. She stocks 100 cans in 2 hours. 1 hour after she starts, there are 60 cans on the shelves. Write an equation to model the situation. So let's think about what we know here. Since we know we are trying to write an equation in the form of y equals mx plus b, let's see what our variables are. Let's define x and y. Take a moment to do that on your own. So the number of cans is a function of time. So we'll let y be the number of cans, and we'll let x be the time in hours. What else do we know? Look for information in the problem to tell us the rate of change. So the problem tells us that she stocks 100 cans in 2 hours. If she stocks 100 cans in 2 hours, how can we use this to tell me how many cans she would stock in 1 hour? Right. If she stocks 100 cans in 2 hours, then in 1 hour, she would stock 50 cans. So the rate of change, or the slope, is 50. What else do we know? The problem tells us that after 1 hour after Tressa starts, there are 60 cans on the shelf. So 1 hour after she starts, there are 60 cans on the shelves. We can use this as an ordered pair. So think, if my ordered pair is x, y, x represents the time. So after 1 hour, there were y, number of cans, 60 cans. We can use 160 as an ordered pair. Do you think that we have enough information to write an equation now? We have the rate of change and we have 1 point on the line. Do we have enough information to write an equation? Right. Since we have the rate of change and 1 ordered pair, we can find the initial value. Let's work through this. Let's start with slope-intercept form and see how far you get. I'm going to give you some time. Okay, did you make it all the way to the equation? And did you get something like this? Y equals 50x plus 10. Here's how I solved it. Follow along with me. So I used my equation, and I'm using my one ordered pair. I know that my Y value is 60. I know that my rate of change is 50, and that the value of X when Y is 60 is 1. So I have that 60 equals 50 times 1 is 50 plus B. So think about this logically. What plus 50 is going to give me 60? Right. So the equation that models the linear function is y equals 50x plus 10, where the initial value is 10 cans on the shelf at the time that Tressa started, and the rate of change is 50 cans per hour that Tressa is stocking the shelves. Okay, let's look at one more situation. A school club is fundraising by selling boxes of homemade desserts. They buy the ingredients for $40 and then box the desserts for 50 cents each. They sell each dessert box for $5. Let's start this situation by writing an equation for the money they spend Y as a function of the number of dessert boxes they buy X. Remember, we are just looking at the money the club is spending. Take a minute to think through it and write down an equation you think fits this scenario. So another reminder that we are looking at the amount of money they spend only. Does your equation look something like this? Y equals 0.50x plus 40. The initial cost is $40 for ingredients. They buy ingredients for $40. So the initial cost is $40 for ingredients. The amount they spend per box for packaging is 50 cents. So they box for the boxes for dessert is 50 cents each. Now, let's look at the equation that would model the money that they collect for the desserts. Y as a function of the number of dessert boxes they sell, X. Take a minute to think it through and write down an equation you think fits this scenario. Remember, we are only looking at the amount they collect. Does your equation look something like this? So this is for the amount they spend. For the amount they collect would be Y equals 5x. Or maybe you wrote Y equals 5x plus 0. In this case, they don't sell any. If they don't sell any dessert boxes, they don't make any money. So the initial value is 0. The amount they collect per box is $5. Last question. Let's see if we can combine these two equations into a statement about profit. Remember that the profit is the difference between the amount collected and the amount spent on supplies. Let's walk through this part together. You will see a similar problem in the student practice today. If we let the profit be Y, then we can state that Y is a function of the difference between the amount collected, or 5x, and the amount spent, or 0.50x plus 40. Follow along and we'll write this out together. So my profit is the amount collected minus the amount spent. So let's substitute in what we know. We know that the amount collected is 5x minus the amount spent is 0.5x plus 40. So now we can simplify the equation by subtracting these, and we get y equals 4.50x minus 40. There was a little bit of tricky arithmetic in that equation simplification. Did you catch it? So we went from here, we're subtracting positive 40, which would make it a negative 40. So the profit or the fundraising amount the club gets will be $4.50 per box, minus the $40 spent on ingredient supplies. One more bonus question. How many dessert boxes does the club need to sell in order to actually make a profit? There are several ways to figure this one out, but you should have come up with they need to sell at least 9 dessert boxes to make a profit. They have to sell those many or that many to recover the cost of ingredients. Terrific. Now I think we are ready for some independent practice. All right, guys, great work today. We explored writing an equation for linear functions from a verbal description in mathematics. I hope this has helped you to make connections between graphs, points, verbal descriptions, and equations that models linear functions. After this lesson, you'll have a few problems of practice on your own, which I have shown you where on this website you can find that. I enjoyed reviewing using functions to model linear relationships in mathematics with you. Thank you so much for inviting me into your home. I look forward to seeing you in our next lesson in the Tennessee's at-home learning series. Goodbye.